In 4.4, we looked at included angles. So if we look at this triangle, we've got two white sides, and this angle on the top is the included angle between those two sides. Now we can have the same idea with included sides. So if we look at these two angles, then the green side is the included side between these two angles. So we're going to look at another two congruence postulates. One of them is the angle-side-angle congruence postulate. So what that means is if we take, say, a side length, so say this green side, and we lock that side so it's not going to change lengths, and then we make two angles coming off of that side and lock those angles. So this angle is not going to change, and this side length is not going to change, and these two angles are not going to change. So think about how many different triangles you could construct with that. Well, if you're not going to move this side length, and if you're not going to change either of these angles, then the only way that you could finish this triangle would just be by extending these sides up until they meet and making a triangle like that. So the only way to finish this triangle is just like that. That's the only way you can do it. There's no other way you can do it without changing the angles or maybe moving this side length. That's the only way that you could finish this triangle. And so this is another congruence. If we have an angle, two angles and the included side between it, then that's going to be a congruence. And so this is angle-side-angle congruence. So all the stuff at the top is what we just talked about. So let's jump down here. So if two angles and the included side between those two angles of one triangle are congruent to the same thing in a second triangle, then the two triangles are going to be congruent to each other. So this is what it looks like with the markings on the pictures. So we've got two sets of angles that are congruent to this set of two angles, and then the sides between them, those are congruent to each other. So that is enough to say that the whole triangles are congruent. So again, this is a shortcut. So rather than saying that every single corresponding piece is congruent, so all of the corresponding angles and all the corresponding sides, instead of proving all of that, we can just prove that we've got these two angles congruent, we've got these two angles congruent, and we've got the side between them congruent. That is enough to say that everything in the triangle is congruent. Okay, so then we can get ABC, triangle ABC being congruent to triangle DEF. The last congruence that we're going to look at is called angle-side congruence, and this is where you have two angles and a non-included side. So we've got, again, these two angles are congruent to each other, these two angles are congruent to each other. Now these sides would be the included side, so what we have here is a side that's not included, and that's okay. That's still enough information to say that the triangles as a whole are congruent to each other. So if we've got two angles and a non-included side of one triangle congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. And so we can say that triangle ABC is congruent to triangle DEF. Now let's look at a couple examples. On the left here, so we're being asked if it's possible to prove that these two triangles are congruent. Well, looking at it as is, we've got angle S congruent to angle U, and we've got segment RS congruent to segment VU. So that seems like it's not enough information. But we do have vertical angles here. So this angle is congruent to this angle because they're vertical angles. And so actually what we have here is two sets of angles congruent to each other with the non-included side. So this side is not between the two angles. So ST would be between the two angles, and then over here TU would be between the two angles. So it's the non-included side. And so then that gives us angle side. So we can say, yes, these are congruent to each other, and we know that they're congruent to each other by the angle side postulate. On the right side, we've got two triangles joined together, and we're told that angle QPR, so that's this angle here, is congruent to angle PRS, that's this angle here, and then similarly with these two angles here, these are congruent to each other. So again, for both of these, we needed a side. We needed two angles and a side. Here we only have two angles. So again, at first glance, it looks like we don't have enough information to say they're congruent, but they share PR. And so we can say that PR is congruent to itself by the reflexive property, which gives us angle side angle. So this side is between the two angles in both triangles. And so this is congruent, or the two triangles are congruent, I should say. And we know that they're congruent by the angle side angle postulate.